Hello, everyone, and welcome to the third lecture in our course, which has the title 100% on-grid renewable energy systems. Also, we will focus on the PV solution in this lecture. Let us start with the guidelines for sizing of grid-tied PV systems. First of all, it depends upon your objective of constructing this on-grid PV system. In most cases, you need same energy that you consume. So at the end of the day, you will not pay to the electricity company or the Ministry of Electricity or the one who is giving you the electricity in your area. You need to produce the energy equivalent to the energy you consume in your house, in your factory, in your farm, in wherever you would like to have 100% PV system. You should know that the input rating of your inverter should be the same as the PV array rating to allow safe and efficient operation. Generally, you don't need energy storage in grid-tied PV systems because most of the cases, the power grids are that reliable and could feed your loads continuously. And for critical loads, there will be UPS or even diesel generators. I believe as diesel generators are not that friendly to the environment, but you don't need to count for batteries in most of the cases for 100% renewable energy system in on-grid basis. And at the end of the day, for the rest of the equipments, you may follow the same of the isolated grid sizing if you need other equipments besides the panels and the on-grid inverter. Because in most of the projects that I worked in on-grid solution for the PV, you just need the panels and connections to the inverter. And then from the inverter, you will connect it to the grid through smart meters to count your generation and your consumption. And then the smart meter could calculate the net, which if you do the sizing in the right way, you will have zero net energy. Your consumption will be equivalent to your generation. Let us focus on a project that I worked in is to turn my university to be working with 100% PV system. Well, to know more about my university and the locations that we worked in to apply our project, which is 100% on-grid PV system, is Heliopolis University for Sustainable Development, is besides the Cairo Airport in Egypt, which is located 22 kilometers far away from the downtown and the middle of the capital, Cairo. Well, we worked in this project in 2021, last year, and our aim is get the grid-tied solution for zero cost operation through installation of 200 kilowatt PV system. And we will find how we calculated these 200 kilowatt to be equivalent to our consumption. The project stages where we calculated the current demand calculation and the future load prediction, and then we calculated the required PV capacity to cover the total kilowatt hours consumed by our university, and we selected the microgrids location in the site, and then the mechanical and electrical connections design. Then we tested the system and we operated it, and it's now working for 1 year. So the system of our university is working for 1 year now. First of all, we began to get the consumption of our university in 2 years. We get the consumption in 2019, before COVID-19 and the, let me say, the online learning. So most of the students in the university never came at that time, and they were getting their education through online basis. And we found that yearly the total consumption is 460 megawatt hour for Heliopolis University in 2019. And then we calculated after COVID-19 in 2020, and we found that the total consumption of our university is almost 270 megawatt hour, which is decreased a lot due to the absence of the students from being in the campus, because most of the education turned to be online. But we know that this will never ever be the same all the time, because the Egyptian Ministry of Higher Education announced that most of the education will be turned to be in hybrid basis. So the students will not come every day, but they will come 3 days per day. So we found an intermediate calculation between the 2 years, and we found it to be like 310, almost 310 megawatt hour consumption per year. So we need a PV that could produce 310 megawatt hour energy per year. And then we came to know what is the PGF, or the peak sun hours of Heliopolis University. As we said about the PGF is a peak sun hour of each location, and we found it in Heliopolis University to be almost 4.5. And then we divide the yearly energy consumption by 12 multiplied by 30 multiplied by the PGF. Because this is a yearly consumption, so we divide it by 12, because there are 12 months, and each month include 30 days, and the PGF is the peak sun hour per day. If we get an average of 310 megawatt hour between the two scenarios, before COVID-19 and after COVID-19, then the installed capacity of the PV we needed, we found it through this calculation to be 200 kilowatt. This means that we need 400 PV panel from the half kilowatt type, or the 500 watt peak type, which we mentioned last lecture. And we need 200 kilowatt grid type PV inverters required in order to connect our PV system with the Egyptian distribution grid. This is a very quick sizing that we did at the beginning, but in fact, we would like to make it like in more details, especially for the calculation of the panel generation factor, the PGF, or the peak sun hours, as I mentioned last lecture. We already have in Heliopolis University since 2013 a 4.5 kilowatt PV system, and here is the let me say the total yield of 2020 for this system. What we did is we calculated the monthly peak sun hours and the daily peak sun hour for each month, and then we calculated the total peak sun hours per year, which was 1,536 hours per year. And we found also that we will get the installed capacity to be 200 kilowatts. So we got the same answer that we did from the quick calculation of our PGF and our sizing of the on-grid PV system in Heliopolis University. In fact, the project, including the panels, the inverter, and everything, costs near £1 million Egyptian pound. And we calculated the payback that we are going to get from paying to the electricity company. And we found that we will get back our money in 1.6 year. Almost 1 year passed from it, so we are about to have our electricity for free for the lifelong of the PV panels, which is almost near 25 to 30 years. So we are going to have, let me say, zero cost electricity for nearly 29 or 28 years, which is excellent for you to have electricity in your house, in your factory, in your farm for free, almost 29 or 28 years. And we then selected the optimal locations to put the PV panels. And we, after discussions and using different programs, we found that the optimal solution is to put 100 kilowatt PV in the roof of the Faculty of Pharmacy, 50 kilowatt PV in the roof of the Physical Therapy faculty, and another 50 kilowatt in the roof of the main office of the university. So we have total of 200 kilowatt system. As an assignment, I would like to help me in a project that I'm already working in now, which is how to convert Lotus factory to be operated by 100% grid-tied PV system or any other 100% grid-tied renewable energy system. Here is the monthly and the yearly consumption of the factory, and here is what we pay in each month to the electricity company. The required is we need to have 100% renewable energy system that could generate equivalent to our consumption. To conclude, this lecture is 100% on-grid renewable energy is highly applicable and easier than off-grid. You just need the panels and the inverter, and the rest of the story will be done with the electricity company. Based on what is here in Egypt, the electricity company is a place which put you the smart meter. In most of the cases, no storage is needed. So the on-grid is usually less expensive, much less expensive than the off-grid solution, because we know that the energy storage is the most expensive part of the 100% PV systems. It's more reliable in operation for any load. Already there is an electricity coming from the electricity company. Smart metering is a way to calculate the net between the energy consumption and the production. And usually your aim is that this smart meter records zero at the end of the year. So your consumption is equivalent to your production, or even you have high production, so you are going to make money upon your tariff in your country from your PV system or renewable energy system. The application shows that the storage plays an important role in 100% renewable environment in off-grid basis, but usually the storage is not needed in most of the cases for stable grids in on-grid basis. So storage is important in off-grid, but not in on-grid. Let me try to remember you. We need to size a 100% grid-tied PV system for this factory, and 100% grid-tied renewable energy system other than the PV, for example, wind, for example, biogas, biodiesel, geothermal, micro hydro system, if you are living beside micro hydro systems, tidal wave. We are open for any renewable energy technology, and we are open also for hybrid systems, for example, PV and wind and tidal. We are okay with any scenario. I would love to do it using other technology beside the PV as an assignment. So thank you very much, and see you in the next lecture.